Okay, so you guys saw in the notes, right, if you're following along there, that we are now in implicit differentiation. The idea was you just simply take the derivative with respect to x, right, if it's y as a function of x, and then you try to solve for y prime, in other words, dy over dx. So, okay, let's try the first example there in the notes, right? You're trying to find the derivative for the following function. We've got x squared plus y squared equals 25. So you might already know what this function represents in 2D space, right? If we were to draw it, right, you'd basically get a circle of radius 5. Right, you could solve this as an equation. You could solve y as a function of x. You could get x squared over on the other side. But then when you take the square root of both sides, you end up with a weird result, right? You end up with this not function. And you could take the derivative here, but it's a piecewise function at this point, right? For x values that are between -5 and 5, you get two results. You can get a positive result, right? Y could be up here, right? Y could be positive, right? Positive y are up here. Or you might get a negative result for that same x value. Like let's say if we chose x was this number, right? Then you get this specific y value and this specific y value. So you'd get two answers. It's alright. That seems a little bit troublesome. And I don't necessarily want to take the derivative of this thing, right? It just looks like a mess. So is there an easier way? Well, let's try implicit differentiation. So here, implicit differentiation, what it says is, okay, I know this side is equal to this side. I'm just going to take the derivative with respect to x of this side. And I know it's equal to the derivative with respect to x of this side. But now, okay, what's the derivative of 25? That's just 0, right? So we could set that equal to 0, right? Derivative of a constant with respect to x, 0. But now I need to ask, what is the derivative with respect to x of x squared plus y squared? So by our derivative rules, I can split that into two separate derivatives by their term. Now, okay, what's the derivative with respect to x of x squared? That was just power rule, right? That's just 2x. Okay. How about the derivative of y squared with respect to x? So y is a function of x, right? So that's our other assumption here. Y is a function of x. So if y is a function of x, we've got to use the chain rule, right? Anyway, we take the derivative of y squared, and that gives us 2y, but y is a function of x, so we also have a chain rule involved, right? So we also get a y prime, but what's y prime? That's just dy over dx. And then on the right side, right, that was equal to 0. So now I can just focus on this piece. 2x plus 2y times dy over dx equals 0. In other words, 2x plus 2y times y prime equals 0. Can I solve for y prime? Yeah, that's easy, right? I just need to subtract the 2x, divide the 2y, and I get y prime is equal to negative 2x over 2y, or in other words, negative x over y. So now I know the derivative, right? Y prime is equal to negative x over y. Interesting. Compare that to what was up here, right? Taking the derivative of this should be a kind of a mess. But these will still give us the correct derivatives. So now, okay, let's give ourselves some space here. We wanted to find the derivative at a specific point too. If we redraw our circle here. So we had a point at 0, so that was 0.50. We also had 0.05, so x is 0, y is 5, that's up here. All right, let's find those two first, and then we'll come back to the last point, which will be right about here at root 12.5, root 12.5. Let's not draw that, we're running out of space there. So, okay, how do I find the derivative at these points? Notice that y prime is defined in terms of the y value being in the denominator. Right? Notice what should happen if I plug in the point up here. What do you guys think the slope should look like for this particular point? Right, if I just follow the general shape of this circle, right, it seems like we should get a slope that looks kind of like that, right, nice and flat. Okay, let's plug in the value. Y prime is negative x over y, so y prime, if I plug in my x, I get a negative 0 over 5. The slope is 0, it's horizontal. That's what I expected. Now, what do you expect here? It seems like the slope is this way, but then it goes back on itself. It's almost as if, right, the slope should be vertical, right, straight up and down. Okay. What happens if we try to evaluate at that point? Y prime is then negative 5 divided by 0. Well, all right. This is undefined, right? That can't happen. We can't divide by 0. Does that make sense, though? As it approaches a vertical asymptote, the slope approaches positive or negative infinity, right? Depending on which direction we're approaching from. If I approach from this way, right, it goes down to negative infinity. Or if I approach from this direction, right, it goes up to positive infinity. Makes sense. We might see something similar if we tried to plug in x is 0 here. We'd get y would be equal to 0, right? We'd go to this exact same point. So you check out what would happen for the derivative here. Would it give us something similar? So let's look at that. Let's write that down here. Right, if I just take the positive, right, the derivative of the positive part, then y prime is equal to, right, this is just, in other words, 25 minus x squared to the 1/2 power, right? Its derivative then is just, we need a power rule and a chain rule. 1/2 derivative of the inside times the inside unchanged raised to that negative 1/2 power, right? Just subtracting 1 from the power. So I could rewrite that as a negative x over root 25 minus x squared. All right, here's the deal. Where's this derivative undefined, right? It's now a rational function, and it's undefined when the denominator is set to 0. When is the denominator equal to 0? Right, when is this equal to 0, question mark? Well, that's when x is equal to plus or minus 5 again. So the slope is undefined when this thing is at plus or minus 5, which makes sense in either form. Okay, so there we go. We found the slopes at those 2 points. This one, nice and easy, right? Just plug and chug. This one, a little bit more work, right? A little bit more computation involved, but not too crazy. Okay, now let's try that last point. Right here, that's at point root 12.5, root 12.5, what do you guys expect the slope to be there, right? It kind of looks like it's at this kind of an angle. Seems like it's got a slope of, roughly -1. Notice what happens then. Y prime was negative x, so root 12.5 over y, which was also root 12.5. We get a slope of -1.